Imagine standing at the base of a structure so tall, its peak disappears into the sky, not behind a cloud, but into the blackness of space itself. This isn't science fiction anymore. This is the space tower. A tower to space, rising 36,000 kilometers, or about 22,000 miles, straight up, stretching from the surface of Earth to geostationary orbit. For centuries, this idea existed only in the minds of dreamers. Jules Verne, Konstantin Tsiolkovsky, Arthur C. Clarke, they all imagined some version of it. But today, let's ask, what if we actually built it? First, the material. No known steel or concrete could support its own weight over such a colossal distance. The solution? A futuristic material, something like carbon nanotubes or graphene ribbons. These would be stronger than any material we've ever built with, yet lighter than aluminum. With this, the tower wouldn't be constructed from the ground up, but from orbit down, anchored in space, with tension holding it upright, like a tightrope hanging to Earth. The base would be massive, perhaps floating on the equator, where Earth's spin would keep the structure balanced. At its peak, a spaceport in geostationary orbit, remaining above the same point on Earth as the planet turns. This station could launch satellites, send ships to the Moon or Mars, or receive tourists in orbit, all without rockets. Inside the tower, elevators would rise on magnetic rails, gliding silently at hundreds of kilometers per hour. A trip from Earth to space would take hours, not minutes, but it would be smooth, gradual, and shockingly affordable. No fiery launches, no stages falling back to Earth, just gravity, electricity, and engineering. The benefits would be staggering. Launch costs would plummet by over 90%. Satellites, observatories, even asteroid mining operations could be built and maintained without sending rockets into space. Energy-hungry nations could send solar collectors into orbit, beaming down clean power 24/7. Developing countries along the equator, ideal locations for the tower, could leapfrog into the space economy, their skylines crowned with the Earth's tallest structure. But this dream would come with dangers. The structure would be vulnerable. Anything that tall would face wind shear, orbital debris, micrometeors, and sabotage. If damaged, the tower couldn't just collapse like a skyscraper. Its upper portions, still in orbit, would whip around the planet at thousands of kilometers per hour, potentially wreaking havoc across continents. To prevent this, advanced AI, self-healing materials, and orbital counterweights would be essential to stabilize it at all times. Politically, it could become one of the most contested objects in human history. Who owns the tower? Who controls access to space? Is it an international gateway or a national weapon? And yet, if we manage it right, it could also be humanity's first, truly global project. A beacon of cooperation, like the International Space Station, but visible from the surface of Earth. A symbol not of dominance, but of unity. From space, Earth would look different, not just because of the tower, but because of what it represents, that we, fragile creatures of the ground, dared to build a bridge to the stars. Would you ride the elevator into orbit? Would you step out at the top and gaze down on the world you came from? Or would you stay grounded, eyes raised forever at the ribbon of human ambition stretching to the heavens? In the end, the space tower isn't just about reaching space. It's about what kind of future we want to build, and whether we can rise high enough to meet it.